Welcome to Lesson HUMAR's Build Systems Knowledge Training. Learning Objectives. This lesson runs about 90 minutes at expert level, and the goal is ambitious. Master the build patterns and workflows of every major build system across C, C++, Python, Java, Ruby, Perl, Rust, and go well enough to train an AI assistant that can reason about all of them. Make sure you've completed lessons 8.1 and 8.2 before continuing here, because we're building directly on that foundation. Build system overview. Here's the reality of building a Linux distribution from scratch. You're not compiling one or two projects, you're compiling hundreds. The Linux kernel, systemd, x.org, OpenSSL, those are C and C++ projects. Your AI and ML tooling is Python. Build tools and IDEs are often Java. Then there's a long tail of utilities written in Perl, Ruby, Go, and Rust. Every single one of those language ecosystems has its own build system, its own conventions, its own failure modes. Your AI assistant needs to understand all of them fluently, not just recognize the commands, but know why each system works the way it does. C and C++ build systems. The classic C and C++ build workflow follows three steps: configure, compile, install. The write single quote /configure write single quote script is generated by AutoTools and does detective work. It probes your system for compilers, libraries, and headers, then writes a makefile tailored to your environment. The prefix flag is the most important option you'll pass here. It tells the build where to install the finished software. Once configuration succeeds, make binos $j$nproc compiles the source, and that binos j flag is critical. It runs as many parallel compile jobs as you have CPU cores, which can cut build times dramatically. Finally, make install dstdir =sign/sum/path copies the finished binaries into place. The dstdir option redirects the install into a staging directory, which is essential for packaging. You never want to scatter files directly across a live system during development. Here's a concrete example: building Nginx from source. After downloading and extracting the tarball, the write single quote /configure write single quote call is where the real decisions happen. The prefix flag the math_decach etc _sll _module and math_decach etc _v2 _module flags opt into SLL and http/2. The WordPress rack pulls in Perl compatible regex support, which Nginx uses for location matching and rewrites. After configuration, make $j$nproc compiles everything in parallel, and sudo make install drops the finished binaries into the prefix use. If you hit errors during configure, they almost always mean a missing development library. We'll cover exactly how to diagnose and fix those later in this lesson. Beyond the Nginx specific flags, there's a set of configure options you'll encounter constantly across almost every AutoTools project. The that's with feature and without feature pattern controls optional components. The enable shared and enable static flags control whether the build produces shared libraries, static libraries, or both. Shared libraries save disk space and allow updates without recompiling dependents, while static libraries produce self-contained binaries. The cflags environment variable lets you inject compiler flags directly. O3 enables aggressive optimization, and march =native tells GCC to generate instructions tuned specifically for the CPU run. That last flag is powerful for performance, but it means the resulting binary may not run on older hardware. Something to keep in mind when building for distribution versus building for your own machine. CMake takes a different philosophy than AutoTools. Instead of a shell script that probes your system, CMake uses a declarative write single quote cmakelist.txt write single quote file and generates build files for whatever backend you choose: Make, Ninja, Visual Studio, and others. The canonical CMake workflow starts by creating a separate build directory and running CMake from inside it. That out-of-source build pattern keeps generated files completely separate from your source tree, which makes cleaning up trivial and keeps version control clean. The CMake invocation accepts options with the D prefix, which we'll see in a moment. After configuration, make meets $nproc compiles the project, and make install deploys it. The separation of configuration from compilation is one of CMake's biggest advantages over raw make. Here's OpenCV as a real-world CMake example. After cloning the repository, you create the build directory and run CMake with a set of D flags that configure the build precisely. CMake _build _type =sign release enables compiler optimizations. Without this, you get a debug build that runs significantly slower. With _coder =sign on activates GPU acceleration, which is exactly what you want with your Tesla P40S. After make $nproc compiles the library, sudo make install deploys it. And sudo ldconfig is the step people often forget. It refreshes the dynamic linker cache so the system actually knows the new library exists. Skip ldconfig and you'll get confusing library not found errors even though the file is sitting right there on disk. Meson is the modern alternative to AutoTools, and Ninja is its preferred compilation backend. Together they're faster than the traditional configure and make workflow, and they're becoming the standard for newer C projects like glib, GTK, and systemd. The workflow maps cleanly. Meson setup build replaces write single quote /configure write single quote. Ninja -c build replaces make, and Meson install -c build replaces make install. The -c build flag. One important difference from AutoTools: Meson enforces out-of-source builds. You cannot run Meson setup in the source directory. That constraint is actually a feature. It keeps your source tree clean by design. The systemd project is the canonical example of a Meson build in the wild. The Meson setup build prefix =sign/usr build type =sign release. Command initializes the build directory with two critical flags: Meson prefix =sign/usr installs into the standard system prefix, which is correct for a core system component, and -build type =sign release enables compiler optimizes equivalent to -O2. From there, Ninja -c build compiles the project. Ninja's incremental build tracking is noticeably faster than make for large projects like systemd. Finally, sudo ninja -c build install deploys the compiled binaries. The combination of Meson and Ninja represents the direction the C ecosystem is moving, and your AI assistant needs to recognize and handle it fluently. Python build systems. Python has three distinct pip invocation patterns that behave very differently from each other. Pip install package is the standard case. It pulls a pre-built wheel from PyPy and installs it. The pip install -ce performs an editable install of the package in the current directory, which means Python resolves imports directly from your source files rather than a copied installation. Changes take effect immediately without reinstalling. Pip install no binary all forces pip to compile everything from source, bypassing pre-built wheels entirely. That last pattern matters when you need a package compiled against specific system libraries, like building NumPy against a locally optimized BLAS implementation rather than the generic one bundled in the wheel. Real example: building NumPy from source. Building NumPy from source is a perfect illustration of why the no binary flag exists. The pre-built NumPy wheel ships with a generic BLAS implementation that works everywhere but isn't optimized for any specific hardware. By installing Python 3dev, leb openblastdev, leb lapacdev, and gfortran first, You give the NumPy build system everything it needs to compile against OpenBLAS, a highly optimized BLAS implementation that can significantly outperform the generic version for matrix operation. Then pip install no binary all. NumPy forces a source compilation that picks up those libraries automatically. The alternative path, cloning the NumPy repository and running pip install myce, is useful when you need to modify NumPy's internals or debug at the C level. Watch the build output for lines referencing BLAS and LAPACK detection. Those confirm the optimized libraries were found and linked. Poetry is a modern Python dependency manager that combines dependency resolution, virtual environment management, and package building into a single tool. Poetry install reads your write single quote pyproject.toml, creates a virtual environment if one doesn't exist, and installs all declared dependencies with their exact pin. This reproducibility is Poetry's core value proposition. Every developer on the project gets identical dependency trees. Poetry build packages your project into distributable formats, a write single quote .plohl, write single quote wheel file, and a write single quote. Poetry publish uploads those artifacts to PyPy. The workflow is cleaner than raw pip and sepicere, and it's increasingly the standard for new Python projects. The write single quote setup.py write single quote interface is the older Python build system, still widely encountered in legacy projects and packages with C extensions. Python setup.py build compiles the package. For pure Python projects, this is mostly organizational, but for packages with C extensions, it triggers actual compilation. Python setup.py install copies the build package into your active Python environment site packages. The more useful invocation for distribution is Python setup.py sdist bdist underscore wheel, which creates both a source distribution and a binary wheel in the. Notice that modern Python packaging has been moving away from write single quote setup.py write single quote toward write single quote pyproject.toml write single quote, but write single quote setup.py write single quote is still everywhere. When a Python package includes C extensions, think NumPy, Python modules, or custom accelerators. Python setup.py build underscore extend myteaser is the development time command you reach for. The minplace flag compiles the C extension and drops the resulting write single quote dot so write single quote file directly into the source tree alongside the Python files rather than into a separate build directory. This means you can import the package immediately from the source directory without installing it. For distribution, Python setup.py bdist underscore wheel packages the compiled extension into a wheel that includes the pre-built binary. The key prerequisite is having Python 3dev installed. Without those Python header files, the C compiler cannot find write single quote python.h write single quote and the build fails immediately. That's a failure pattern we'll address directly in the troubleshooting section. Java build systems. Maven is the dominant build tool in the Java ecosystem, and its commands follow a life cycle model. mvn clean install is the workhorse command. Clean removes everything in the target/directory from previous builds, and install runs the full life cycle. Compile, test, package, and copy the resulting JR or var into your local Maven repository at write single quote tilde slash .m2.mvn package runs the same life cycle but stops before the install step. It produces the artifact in target slash without touching the local repository. mvn test runs only the test phase, which is useful for rapid feedback during development. The key thing to understand about Maven is that it's opinionated about project structure. Your source code lives in src/main/java, your tests in src/test/java, and Maven expects that layout without configuration. Real example: building a Java application. The full Maven workflow for a Java application starts with apt-get install Maven, which pulls in Maven and a compatible JDK as a dependency. from inside your project directory. mvn clean install is the command that does the heavy lifting. It wipes the previous build, resolves all dependencies declared in write single quote pom.xml write single quote by downloading them from Maven Central, compiles your source code, runs your tests, and packages everything into a jar. The output from Maven is verbose and structured by lifecycle phase. Watch for build success at the end and note the path to the generated artifact in target slash. If any test fails, Maven aborts the build at that point. You can override this with might they skip tests during development, but never ship an artifact built with skip tests. Gradle is Maven's main competitor in the Java world, and it trades Maven's XML configuration for a Groovy or Kotlin DSL that's considerably more expressive. The write single quote dot slash Gradle write single quote wrapper script is the correct way to invoke Gradle. It downloads and uses the exact Gradle version pinned in your project, ensuring reproducible builds regardless of what's installed system-wide. Write single quote dot slash Gradle build runs the full build lifecycle, compile, test, and assemble output artifacts. Write single quote dot slash Gradle assemble produces the output artifacts without running tests, useful when you need a quick build for manual testing. Write single quote dot slash Gradle test runs only the test. Gradle's incremental build system is one of its standout features. It tracks which inputs have changed and skips tasks whose outputs are still valid, making repeated builds significantly faster than Maven on large projects. Android development is where Gradle is essentially universal. Inside an Android project directory, write single quote dot slash Gradle assemble debug compiles a debug APK with debugging symbols and development certificates. This is the build you install on a device for write single quote dot slash Gradle assemble release produces an optimized minified APK suitable for the Play Store with ProGuard or R8 code shrinking applied. Write single quote dot slash Gradle. One thing to notice, Android projects always use the Gradle wrapper rather than a system Gradle installation, and the wrapper version is checked into source control. This means the build is fully self-contained. Anyone who clones the repository can build it without installing Gradle separately. Ruby, Perl, Rust, and Go. Ruby package management centers on two tools, Gem for individual package installation and Bundler for project-level dependency management. Gem install package installs a Ruby gem globally, making it available system-wide. Inside a project, bundle install is the command you actually use. It reads the gem file, resolves the full dependency graph, installs every required gem, and writes the exact resolved versions to write single quote gemfile.log write single quote. That log file is critical. It ensures that every developer and every deployment environment installs exactly the same gem versions, eliminating the works on my machine class of dependency bugs. Commit your write single quote gemfile.log write single quote to version control. It's not an artifact to be ignored. Perl's package ecosystem lives on CPAN, the Comprehensive Perl Archive Network, and there are two tools for installing from it. cpin module name is the traditional cpin shell. It works but can be verbose and occasionally requires manual intervention for dependency resolution. cpin module name cpin- is the modern replacement. It's faster, handles dependencies automatically, and requires no configuration. For most purposes, kpanm is the right choice. When you run either command, watch the output for dependency resolution messages. Perl modules often have deep dependency trees, and both tools will pull in everything required automatically. Rust's build tool is Cargo, and it's one of the most capable build systems in any language ecosystem. Cargo build release compiles your project with full optimizations enabled. The release flag is essential for production builds because debug builds in Rust are significantly slower at runtime. The compiled binary lands in target/release/cargo test runs your test suite, including both unit tests embedded in source files and integration tests in the tests/directory. Cargo install package installs a Rust binary crate globally, making it available as a command line tool. One of Cargo's major strengths is that it handles dependency resolution, compilation, testing, and installation through a single unified interface. There's no separate configure step or external build file generator. Go's build system is built directly into the language toolchain. Go build -o output underscore binary compiles your program and writes the executable to the file MIME you specify. Go mod download fetches all dependencies listed in write single quote go.mod write single quote and caches them locally. This is worth running explicitly before a build-in environments without reliable internet. Go/test/ runs all tests in the current module, with SLA being the pattern that matches every package recursively. One of Go's defining characteristics is that it produces statically linked binaries by default. The resulting executable includes everything it needs and has no runtime library dependencies. That makes deployment straightforward. Copy the binary, run it. Debian packaging. Check install is an elegant tool that sits between make and make install. After you've run write single quote /configure write single quote and make to compile software from source, instead of running make install directly, which would scatter files across your system with no record of what went where, you run sudo check install. It intercepts the install process, tracks every file that would have been placed on the system, and bundles them into a proper write single quote .deb write single quote package. That package is then installed through dpkey, which means you can cleanly remove the software later with dpkey-r. For a distribution builder, this is the difference between a system you can maintain and one you can't. When you need full control over a Debian package, you build it manually. The structure is straightforward. Create a directory named after your package, add a Debian subdirectory for metadata, and mirror the target fee system layout for your files. So a binary going to /usr/local/bin lives at my package /usr/local/bin/ in your. The Debian/control file is the heart of the package. It declares the package name, version, architecture, maintainer, and description that dpkg and apt use to manage the package. Once the directory structure is populated, dpkd-bil my package compresses everything into a write single quote .deb write single quote file. The result is a proper Debian package installable with dpkd- for packages that need to conform to full Debian packaging standards. With proper change logs, copyright files, and build rules, the dh_make and de-build workflow is the path. dh_make create org scaffolds the Damian/directory with template files for everything the Damian packaging system expects. You then edit Damian/control to declare your package metadata and dependencies, Damian/rules to define how the package is built, and Damian/changelog to record the version. With those files in place, dbuild -us-uc builds the complete source and binary packages. The -uc flags skip GPG signing, which is appropriate during development when you don't yet have a signing key configured. Common build failures and fixes. This configure output is one of the most common failures you'll encounter. Package requirements OSLS =1.0.1 were not met, followed by SSL libraries not found. What this tells you is that the configure script found pkgconfig, asked it about OpenSSL, and got nothing back. The root cause is almost always the same. The OpenSSL development headers aren't installed. The runtime OMSSL libraries are present on most systems, but the header files and pkg config metadata that build systems need live in a separate .dev package. The fix is a one-liner and we'll run it in the next step. Two commands, two purposes. App cache search, libssl vertical bar grepdev searches the package database for SSL development packages. This is how you discover the correct package name when you're not sure. On a Debian or Ubuntu system, you'll typically see libssl.dev in the results. The second command, apt-get install libssl.dev, installs that package. What libssl.dev provides is the OpenSSL header files. Write single quote ssl.h, write single quote, write single quote crypto.h, write single quote, and the others, plus the pkconfig metadata file that tells the config. After installing it, rerun your write single quote ./configure write single quote command and the SSL check will pass. GCC tokens named command not found and G++ not found during a make run means the GNU compiler collection isn't installed or isn't on the path. This is the most fundamental build failure possible. You have source code but no compiler. On a minimal Debian or Ubuntu system, this is actually a normal starting state. Compilers aren't installed by default. The fix is apt-get install build essential, which we'll run next. Notice that this failure happens at the make stage rather than the write single quote ./configure write single quote stage. Some configure scripts check for the compiler explicitly, but others don't, so the error surfaces later during actual compilation. apt-get install build essential is the single command that transforms a bare system into a capable build environment. The build essential meta package pulls in GCC, G++, the make utility, the C standard library development headers, and dpkg-ev for Debian pack. It's the foundation everything else depends on. After this command completes, you have a fully functional C and C++ compilation environment. On a fresh system or a minimal container image, this is always the first thing to install before attempting to build anything from source. Fatal error, python.h, no such file or directory, is the Python equivalent of the missing OpenSSL headers. It appears when you're compiling a C extension that embeds or links against the Python interpreter. The compiler needs Python's header files to know the layout of Python's internal data structures. The header files are not part of the standard Python runtime package. They live in the Python 3dev package. This error is extremely common when building packages like NumPy, Pillow, or any other Python library that includes compiled C code. The fix is straightforward. apt-get install python 3dev installs the Python 3 development headers, write single quote python.h, write single quote, and the rest of the CPython API header files along with the static library needed for embedding Python in C applications. After installation, the headers land in write single quote /usr /include python3.x /rcore, and the compiler can find them automatically. Watch the installation output for the exact package version being installed. If you're building against a specific Python version, make sure Python 3dev corresponds to the interpreter you're actually using. On systems with multiple Python versions, you may need write single quote python 3.11-dev write single quote, or similar to target a specific version. Package foo not found from pkg-config followed by checking for FOA no from a configure script means the build system cannot locate a required library's metadata. pkg-config works by reading write single quote .pc write single quote files that describe where a library's headers and binaries live, and those write single quote .pc write single quote files are installed by the library. The library itself might be installed on your system, but without the dev package, pkg-config has no way to find it. This is a pattern you'll see constantly when building software with many dependencies. The diagnostic workflow for a missing PKA config package has two steps. First, apt cache search foo vertical bar grep dev searches for the development package. The naming convention is almost always libname-dev, so for a library called foo, you're looking for libfoo-dev. Second, apt-get install libfoo-dev. After installation, pkgconfig mod version foo is your confirmation command. If it prints a version number, pkgconfig can now find the library and your configure script will succeed. If pkgconfig board version still fails after installing the dev package, check that the write single quote.pc write single quote file was installed with dpag-l. Build system training dataset. Velfjordstum training dataset. Velfjords training kkus t and training t. This Python script is the data generation engine for everything we've covered in this lesson. It constructs a structured list of build system examples. Each entry is a dictionary with fields for the instruction, the command, an explanation of what it does, a category like C/C++ or Python, and the context in which you'd use it. The script covers autotools, CMake, Meson, pip, poetry, Setiverse, Maven, Gradle. After building the list, it serializes everything to write single quote build patterns.json write single quote in your training data directory and prints the total count. That count is your sanity check. If the number is lower than expected, a loop didn't execute or an append was missed. This structured format maps directly to the instruction tuning format your fine-tuning pipeline expects. Build system knowledge matrix. This table is your reference map for everything covered in this lesson. Each row gives you the language, the build tool, the configuration file that drives it, the command to build, and the command to install. A few patterns worth internalizing. Every ecosystem has exactly one file that is the source of truth for dependencies and build configuration. Write single quote cmaculist.txt.car. Write single quote pyproject.tml.car. The install command deploys those artifacts. When your AI assistant encounters an unfamiliar project, the first thing it should do is identify which configuration file is present. That immediately tells you which build system you're dealing with and which commands apply. Completion checklist. Next steps. Build system knowledge complete. You can now reason about how software gets compiled, packaged, and installed across every major language ecosystem, and more importantly, you understand why each system makes the choices it does. That depth is what separates an AI assistant that gives generic answers from one that gives correct, actionable ones. Next up is lesson 8.4, the multi-stage training pipeline, where all of this domain knowledge gets wired into a training workflow that actually teaches a model to use it. Zaskibitons, Zaskibitons, Saskibitons, Saskibitons, Gassigskip, Gassigskipaquis, Fantados, Gassigskipaquis, 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 Skipski. Why does this work? The science behind it is fascinating. Through careful analysis and practice, you'll master these techniques. Zaskipsikityu, 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 squiggly. Zaskipsikityu, Zaskipsikityu, squiggly ha, Sekipsikityu, Sekipsikityu, Zaskip ya, Zaskipra, ya, 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 ya. Ya, 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 ya. Zaskipra, ya, 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 ya. Zeskip, zapisek, city, sekis, quickly. Doses city, sek, city, sekis, quickly, sodes.